these are the notes for 1.3 Part 3, which is solving equations with variables on both sides, and we're also going to talk about types of equations. If you write down 1.3 Part 3, that's enough, but you can write down the rest so that you can refer to these notes to know what they are on. So our first example here is to solve this equation, and you can see right now that on both sides of this equal sign, there are variables. I have x's on this side, and I have x's on the right side. So what we're going to have to do is at some point, we're going to get those x's so that they're all on one side. All right, so we're going to start this off like we normally would. I see these parentheses here, and to me that's saying we need to distribute. We can't work with that x minus 5 until we get it out of the parentheses. So we're going to go ahead and distribute this -2. Now remember, the 5x, he's just kind of hanging out there. Now we need to do -2 times this 1x. -2 times 1 is -2, and we have the x there. So it's -2x. And then we need to do -2 times -5, and that's +10. So all I've done so far is just simplify this side of the equation. So the other side, there's just two terms here, and I can't combine them, so I'm just going to leave them for now. Now, before you even start worrying about the fact that there's x's on both sides still, see if there's anything you can still simplify. So if we look at the left side of our equation, we can combine some like terms. We can do 5x minus 2x, and that is 3x. We still have the +10, that didn't change. And we still have 7x minus 2 on the other side. Now here's where we need to start worrying about the fact that there's x's on both sides. We can't get an x by itself if it's spread out. The x does not like that. He likes to be all in one place. We typically work with the x on this side of our equation, so I generally like to move it over there, but it works either way. So we're going to move this +7x so that it's over here with the 3x. Now to move this term with the x, since it's all by itself, it's separated from this 2 by a plus or minus, we have to undo it with either addition or subtraction. That's how we move it. So to move a +7x, we're just going to subtract 7x from that side. That'll go away. Now, as long as you do it to the other side, you can do that. So we're going to subtract 7x from each side. Let's see where that gets us. So over here, we have 3 minus 7x. That's -4x. The +10 didn't change because that is a constant. It can't be combined with the -7x. On the other side, 7x minus 7x is 0, so we're just left with -2. Now, we've just got a regular two-step equation here like we've been solving. So if I extend that line, I just need to get this x alone. He doesn't like that -4 or that +10. And we have talked about how we want to undo the addition and subtraction first. So we want to subtract 10 from each side first. That's gone. And then let's write what we're left with. So we are left with -4x equals -2 minus 10, which is -12. Our last thing we need to do is we need to get this x away from the -4. It's being multiplied, so we need to divide by -4 on each side. So we are left with x equals -12 divided by -4 is +3. I know it's a lot of steps, but at least it's all things that we've been already learning about. It's just being very meticulous and being very careful with your work, especially your signs as you work through these. So I have one that I want you to try. It's on the next slide. Here's the problem that I want you guys to write down and try. X minus 5 equals 6 minus 3 times the quantity x minus 7. So go ahead and you're going to need to do some distributing and probably combine like terms. Then get all your x's on one side and then solve for x. Refer back to the previous problem for help with that. Pause this and try that one. All right, so now we're going to talk about types of equations. Go ahead and write down types of equations. There's three types of equations, and we touched on this a little bit in class already, possibly. So the first kind of equation is one that we've been talking about a lot, and it's called a conditional equation. Okay? A conditional equation is sometimes true. Okay, so those are problems like the previous one that we did all together. The very first problem I did today, we got x equals 3. That's saying this equation is true conditionally if x equals 3. So the answer for a problem like this will look like this, for example, x equals 6. Okay, so if we're making a little chart here, this is the type of equation. This is how often or when it's true. And then my last column is what does our answer look like. So if you just get a regular answer like x equals 5, z equals 1, that's a conditional kind of problem, kind of equation. That's what we've mostly been talking about. Now, sometimes some weird things happen. So one weird thing that happens is, and I believe we saw it on the worksheet yesterday, problem number 7. It is called, the problem type is called a contradiction. Now, this happens when you're going through a problem and you end up with something weird that's never going to work. It's never true. That's what happens in a contradiction. It means no matter what you plug in for x, you're never going to get those two sides of the equation to equal each other. So you might end up with something like 0 equals 7, or something like x plus 1 equals x. You can't take a number and add 1 to it and have it still be the same. That's never going to happen, so it's never true. So if you end up with a number equals a totally different number, it's never true, and what you're going to write for your answer is you can either write no solution, and you have another option. You guys are going to love this because I know you don't like writing out no solution. You can write the symbol for the empty set, which means no solution, and it's a 0 with a slash through it like that. You have to write it just like that, and that means no solution. So that's a contradiction type of equation, and the answer to those is no solution because the problem presents a contradiction that can never be true. Our last type of equation, when something weird happens, is called an identity. This is something that is always true. So when you're solving your equation, it's going to have something at the end like x equals x. And you might think, well, yeah, of course x is x. It's the same exact thing. Or it might be x plus 1 equals x plus 1. You could plug in whatever you want for x there, and both sides of the equation will be the same. So it's always true. What you write for that is you write all real numbers, because any real number you plug in there is going to work. All real numbers. And again, on this one, you have an option if you want. I know you'll like this. For all real numbers, the symbol for that, we saw it in your book once already, is an R, and you use 2 lines for the vertical part of the R. That means all real numbers. It means the set of all real numbers. So those are the 3 types of equations we're going to talk about. Now we're going to do some examples where we have to tell whether an equation is conditional, contradiction, or an identity. So here's our first example. We're going to do 3. It says solve, and then we're going to classify it as conditional, an identity, or a contradiction. So go ahead and write down this problem and we'll solve it. Alright, so as soon as you see parentheses like this, we know the first thing we need to do is distribute. So I'm going to go ahead and I'm going to leave the left side of my equation the same, 2x plus 7. On the other side, we're going to distribute. 7 times x is 7x, and 7 times 1 is 7. The minus 5x is just hanging out back here. He's not being distributed or anything. So we did our distribution. Now, hopefully you're seeing right now that we can simplify a little farther on the right side. We can combine some like terms. 7x minus 5x is 2x. So we really have 2x. The plus 7 is still there. And on the other side of the equation, we have 2x plus 7. Now this is where you might already see something weird going on. See how both sides of the equation are the same? You can plug in whatever you want for x. Let's say we're going to plug in 1 for x. That will be 2 times 1 plus 7. 2 times 1 plus 7. You don't have to write this part. Well, 2 times 1 is 2 plus 7 is 9. 2 times 1 is 2 plus 7 is 9. Well, yeah, 9 is 9. You can plug in whatever you want for x. Both sides of the equation are going to be the same. So this equation is always true no matter what you plug in for x. So we're going to classify this as an identity because it's always true, and our solution is all real numbers. Remember, you can write, if you want to write the symbol for the solution set of all real numbers, you can write that. All right, let's try 2 more of these problems where you get kind of a weird answer like that. Oh, and I wanted to point out, if you kept going with 2x plus 7 equals 2x plus 7, let me write that down here. If you tried to solve it, well, okay, we need to get all our x's on one side, so we can subtract 2x from each side. Those go away, those go away. So we're left with 7 equals 7. So if you get a number equaling itself, that also tells you it's an identity. All right, here's the second one I want to try. 3x minus 5 equals 3 times the quantity, x minus 2, and then we're going to add 4. Let's simplify what we can here. This left side we can't do much with right now, but on the right side, we can do 3 times x is 3x, and 3 times negative 2 is negative 6. This plus 4 is not being distributed. It's not in the parentheses. It's just hanging out on the outside, being added, separate term. Let's go ahead and simplify some more on the right side. So the 3x can't be combined with anything, but negative 6 plus 4 is negative 2. So we have 3x minus 2 here. On this side, we have 3x minus 5. You might already notice something weird here. But let's keep going and let's say, well, I want to move all my x's to be together. So I'm going to subtract 3x so I can move it over to this side. Well, 3x minus 3x is 0. So those go away. I'm left with negative 5 equals negative 2. That's weird. So that's saying that this equation is never going to work. Whatever you plug in for x, if you do 3 times the number and subtract 5, it's never going to be the same as 3 times that number and then only subtracting 2. Those are never going to be the same. It's never going to be true. So we classify this as a contradiction. It does not work ever, no matter what you plug in for x. It's a contradiction, and our solution set is no solution, or you can write the 0 with a slash through it, which means the empty set, no numbers. No numbers work there. All right, one more together, and I've got one more for you to try. Here's our last one. Same instructions. We're going to classify it, and we're going to tell what the answer is. This one's pretty nice. There's not really a lot of simplifying to do, but we do have x's on both sides, and x doesn't like being split up. It just feels like it's crazy if that happens. So we need to move all our x's to the same side. Like I said, I usually like to move my x's to the left. So to move negative 7x, we need to add 7x to each side. Negative 7x plus 7x is 0. On the other side, this 3 cannot combine with 7x. They're not like terms. So the 3 is just hanging out. Now we've got negative 8x plus 7x. That's negative 1x. You can either write minus x or minus 1x. Equals, the other side's just 5 now. We need to get this x all alone. He doesn't like these other numbers over here. We have to undo the adding and subtracting first. We work from the outside in. So the farthest thing from that x is this 3. we need to subtract 3 from each side. So we are left with negative x, or negative 1x, equals 5 minus 3, which is 2. Now, even if you just have negative x written here on this side, you can't leave negative x. It really means negative 1x. So we need to get rid of that negative 1 that's being multiplied by dividing by negative 1. So we are left with x equals negative 2. What a nice answer. So this is a conditional statement. And our answer was x equals negative 2. We're saying this equation is sometimes true on one condition. X has to be negative 2. So it's conditional and x is negative 2. Those are the normal type of equations. Normal is in quotations. Those are normal types of equations because those are the kind we usually see. One more for you to try. I want you to solve this and then tell me whether it's an identity, a contradiction, or a conditional equation. All right, see you guys tomorrow.